I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics,
medicine,
nature,
or
space, time,
the brain,
life, the universe.
Hello, this week, if it's in the sea, is there plastic in the fish that we're eating too? Also, can electrical devices affect your fertility? And how does the Earth's tilt give us our seasons? This week, we're taking on the science questions that you have been sending in. I'm Chris Smith, and this is The Naked Scientist.
The Naked Scientist podcast is powered by ukfast.co.uk.
Now, just before we start the programme properly, I do have a very important announcement to make, and that is that we're launching our Christmas appeal. I will give you much more in the way of details at the end of the programme, but we do need your help, and we've explained how we need you to help us on our website at nakedscientist.com/donate. Right, let's introduce the panel of people who are here to solve your scientific quandaries and conundrums this week. Or should that be conundra? Danny Green is from Anglia Ruskin, and she's also an ecologist. The oceans have really been in the spotlight this year, haven't they, with all the plastics and things?
Yeah, well, I mean, it's great because I've been working on plastics the last 7 years, and thanks to the Attenborough effect, we've finally got pretty much global consensus that people are interested in this and they want to solve the problem, so it's great.
How much rubbish actually is in the oceans in terms of plastics?
A lot.
Do you actually know?
I think 320 million tonnes are produced every year, and around 10% of that makes its way into the rivers and waterways as litter.
Goodness. And once it's there, it just doesn't go anywhere.
It doesn't, or it breaks down into smaller pieces called microplastics.
Which we're going to find out about. So Danny's here to answer any questions about marine biology and marine science and plastics in the ocean. So if you'd like to ask her a question, now is your chance. Sitting next to Danny is Tim Revel. He is the assistant news editor at New Scientist. So you should be across lots of hot science stories, lots of things coming across your desk all the time.
Yeah, we have loads of big stories all the time, and often talking about artificial intelligence or the latest technology such as 3D printing. But one of the big ones we've had recently was questioning arguably the biggest discovery in physics in the last few years, and that is gravitational waves, whether we actually spotted them or not.
Why are people sceptical?
It all comes down to the fact that it's so difficult to spot gravitational waves because even though they're caused by massive events in space, by the time they get to Earth, they're very, very tiny ripples. We're talking about measuring something smaller than the size of a proton. So actually being able to find them is really, really difficult and involves lots of data processing and analysis and algorithms. And all of that means that it's a bit tricky for someone else to check the work of the people who've done it. And so when people have come in afterwards and had a look at what they've done, they've sort of said, maybe you have made a mistake. And that's where the difficulty lies.
I think Bill Bryson argued that one of the smallest things in the world is some of the components in an Airfix kit, which he said are roughly on the scale of a proton. I think I'd be inclined to agree with him. Anyway, Tim's here to answer your questions about things relevant to technology. James Pope is a newcomer to the programme. Welcome, James. He's from the British Antarctic Survey, and you study climate. But why is everyone obsessing about the poles? Because no one lives at the poles, really, do they? So why is it important to study the poles when the majority of the world's population are not there?
The polar regions are just so important for climate change. You've got ice sheets, which can affect sea level rise. You've got sea ice, which can affect the temperature at the high latitudes and maybe accelerate warming in these regions. And also very important for uptake of carbon into the oceans, heat into the oceans, and even the circulation, which can affect the nice warm temperatures we have in the UK.
So in other words, it really matters what goes on in the poles because it does have an impact here, whether we like it or not. And I guess it's also a barometer for what's going to happen everywhere. If you look at what's happening in the poles, it's a reflection on what's happening worldwide.
Yes, people talk about the poles as being sort of the canary in the coal mine.
Thank you very much, James. And also with us is Laura Carter-Penman, who is a fertility nurse at Bourne Hall. I guess it doesn't take too much explanation of what fertility is, but what does a fertility nurse do?
We assist people through their fertility journey. We advise them on what is the best course of action, what is the best treatment, and we also provide quite a strong counselling role because, as you can imagine, for patients it's a very stressful time, and we support them through that journey. If they've got a question about their fertility that they'd like to ask, I'd be happy to help.
And there should be no pregnant pauses in the programme.
Fingers crossed.
Now, before we dive into the questions, for those of you at home, we've got a little Guess Who quiz running through the programme. We did this last week, so our congratulations to Nick D, Faye Briggs, Jenny Laville and Strawman, who all got in touch and messaged us with the right answer. We're going to be scattering clues to the mystery Who Am I right through the programme, so listen up for those clues and see if you can work out who or what makes this sound. What do you think? All will be revealed later. More clues on the way. Now, we've got Steve on the line from Telford for you, Danny. Hello, Steve.
Hi. My question is, if microplastics are affecting the fish in the oceans, is this now in the food chain that we are consuming?
Thanks for your question, Steve. Short answer is yes. There's been quite a lot of evidence finding microplastics in fish that we eat, also in bivalves, animals that we eat whole, because quite often the microplastics are in the guts of the animals. But actually, we've found microplastics in honey, beer, tap water, bottled drinking water, pop drinks. It's in our food, yeah.
Why does it matter, though? I guess is that what you're worried about, Steve? The fact that if we're eating it, we're getting a diet of plastic, but does that matter?
To be honest with you, I watched the programme on BBC about the plastics in the ocean, where they said there was 55 trillion pieces of plastic there. So I did a bit of research myself, trying to find out anything about it, and within an hour, what I found was quite horrific, with estrogen being one of the main things that was being released into the oceans. When that gets in the food chain, then it's going to affect the male population as well as the female population if it's not already been doing it for the last 20, 30 years or so.
Danny?
So there is some evidence that microplastics can absorb these other persistent organic pollutants. But the evidence is inconclusive, actually, because some studies have found that they can absorb these things from the water column and they keep hold of them and then they get pooped out the other end and actually stop the animal from absorbing them into their own body. And other studies have found the opposite, that they release them. And given that there's been evidence that microplastics are in human poo, researchers in Austria, and it's a preliminary study, it's not a published piece of work yet, so take it with a pinch of salt. But it's very likely that we are eating them. Take it with a pinch of microplastics. It's very likely that we are eating and inhaling microplastics, so we definitely need more research to find out about these other effects.
And Laura, what about the point that Steve makes about estrogens and things like that? These are female hormones that are in water that might be picked up by these plastics and then get into our bodies. Is there evidence for that sort of phenomenon?
Yeah, there is evidence out there that is occurring and that there are higher levels of estrogen within our waters.
Does that make a difference?
It does make a difference because it's impacting on the male factor, and it's actually then leading on to reductions in sperm because it's affecting testosterone production as well. So it's something that we need to be aware of.
There's evidence that some aquatic animals are also being impacted, isn't there? I mean, we've seen fish changing sex and so on. Is that through this phenomenon?
Yeah, so that's through this phenomenon, not linked to microplastics directly, but linked to the estrogen in the water, nonetheless, from the contraceptive pill. Yep. So fish, seals, so marine mammals as well, and other invertebrates too. Danny,
are scientists actively monitoring this, and do they have any solutions? Because I know we know that there are plastics in the ocean. It's one thing to say they're there; it's another to actually do something about it. Can we remedy this?
I think in terms of trying to remove microplastics, I think it's going to be very difficult because most of them sink. So 98% of them sink to the benthos, to the seafloor. And obviously, if you're trying to dredge them out, you're going to cause more damage than good. In terms of trying to remedy the situation, I think prevention is better than cure in this case. We need to stop putting it into the oceans.
Yeah. So basically, we've done what we have done, but now we've got to
we need to switch
the evil worse.
Safer plastics as well, so BPA free, which a lot of drinks companies have already done.
Well, thank you, Danny. Tim, up in the air now for you. Robert wants to know how high and how fast could all-electric aircraft fly, and how far away are we from actually having an electric aeroplane as reality?
I'd say we're still quite a long way from the reality of flying around rather in sort of jumbo jets like they are, but electric versions. That's not happening anytime soon. And the problem is with electric aircraft is it just takes so much energy to fly anything, But with an electric aircraft, you need a lot of batteries, and batteries are really, really heavy. And the heavier something is, the more energy it needs, so the more batteries you need. And if you've ever flown a drone, you will have seen this. You get these tiny little drones that get into the air really, really quickly and are a lot of fun to fly around, and 8 minutes later your battery is flat. You can get some slightly bigger drones, but even the big ones, they're much, much heavier, but even those can only fly for 30 minutes or an hour. We're talking about very short periods of time. But that's not to say we don't have any electric planes. There are some that have been successful, and perhaps the most famous one is called Solar Impulse 2. And this one had solar panels on it and was created by a Swiss team, and in 2015 it circumnavigated the globe. But the problem was it had to keep stopping, and the whole journey took 16 months, and it only had room for one person. So that's sort of the height, as it were, of electric planes at the moment. And so to answer the original question, how high and how fast, well, Solar Impulse 2 travelled at about 70 kilometres an hour, which is sort of 43 miles per hour, and was about 12,000 metres in the air, or about 40,000 feet. So in terms of height, that's about the same height as a jumbo jet. We're talking similar sort of distance into the air. But in terms of speed, a jumbo jet will easily do 500 miles an hour. It was doing 43 miles an hour. So we're a long way off of that. But people would love to have electric aeroplanes because air transport is an absolutely terrible polluter of the air and is also adding to our greenhouse gas emissions. So is also bad for the environment in many, many different ways. The problem is we just don't have good enough technology yet to make flying aircraft that would be sustainable and do the job that aircraft currently do.
It seems like all of these issues related to transport come down to batteries and energy supply, don't they? And it's like we're sort of at the precipice here, and we really need to solve this problem. And no one's yet managed to get over this sort of chasm of how we get enough energy packed into something that doesn't weigh more than the aeroplane at the moment, and all its fuel and all its passengers. Because that's the problem, isn't it? They're just so heavy, as you say, and it's holding back technology for phones, it's holding back technology and other communications devices, it's holding back technology for cars and so on.
Yeah, so in terms of things like cars and even trucks and also boats, they're perhaps more promising than electric planes because the weight isn't as much of an issue. Yes, you still have to get going, but actually once you get going, keeping it going is not nearly as hard as it is to keep something in the air or to get it into the air in the first place. And so we're already seeing electric cars sort of making it onto the streets, and there are the first examples of electric trucks and also electric boats that might be able to clean up those industries before we start cleaning up planes.
Thank you for that, Tim. And now moving on, James, can you help us with this? Kate Stockings is a geography teacher. She's been in touch. How big a problem really is climate change? Because it's never out of the headlines these days. Is the planet in real danger, or is this just hot air?
My wife will identify with this piece of pedantry, but I always like to say it's never the planet. When we talk about climate change, we're talking about particularly us as human beings, but also the other animals alive. The planet will carry on regardless. But ultimately, climate change will be as bad as we choose to make it. The Paris Climate Agreement, coming up on 3 years old now, led to a pretty landmark statement and agreement from so many governments around the world. And that, the 1.5 degrees Celsius warming, which we've already had 1 degree of, to limit that by the end of the century would be really huge. And if we can do that, probably climate change will not be that bad. Very much we can adapt to that. But that will require quite a strong response. We're looking at 50% cuts in emissions of carbon dioxide by 2030, and then a complete removal of or a net removal of all our carbon dioxide emissions. So we take out everything we put in, or we don't emit anything at all by 2050. So that's really, really very soon when you start to consider it. It's 12 years to 2030. So it's up to us, really.
Thank you, James.
The effects of sibling aggression can be more significant than we once thought.
100 electrodes to link my nervous system with a computer and then onto the internet.
The Naked Neuroscience podcast explores the workings of the brain and the nervous system in our bodies and beyond.
That sticks and stones may break your bones, but words and neglect might hurt your brain.
So you've got the little brain slice in the recording chamber.
From unravelling Alzheimer's disease to digging into dreams, join me, Katie Haylor, each month as we make connections with scientists around the world and spark up conversations on the latest neuroscience news. You can listen and download for free at nakedscientist.com/neuroscience or subscribe to Naked Neuroscience wherever you get your podcasts.
This week on The Naked Scientists, we have a panel of experts who are taking on your science questions. On the way, does the Earth's tilt affect our climate? And are rising sea levels really a problem? Before that, though, here's the next part of our Guess Who game for you at home. We played you a strange noise that this animal makes to start with. Here's our clue 2. Its eyeball is bigger than its brain. What do you think it is? Now, Laura, what about this one? There's been a bit of discussion on the forum. I wonder if you can help with this question from Paul Harrington, who asks this.
Can electrical devices reduce fertility? And is it true that tight boxes are bad for sperm?
So what do you think?
Well, the plain answer is yes, they can affect. There's minimal research about sort of mobile phones and things like that. Clearly, we don't want to be putting a mobile phone on somebody's testicles for a month to see the effect of the sperm on it.
But aren't we effectively doing that, Laura? If you ask most men, where do you keep your mobile? It's in their pocket. And where's their pocket? Right next to their nether regions.
Exactly. So we would be recommending that you put it in your top shirt pocket if you have one, or your back pocket. Or, you know, you see these people, you know, you've got your runners out there where they have this strapped onto their arms.
Phone.
The other thing that we obviously like to do, we're of a generation of Netflix watchers and what have you, lay in bed with your laptop. And where do you put it? Slap bang on your groin. That's about the worst place that you can have it. It's all to do with heat. And actually, the reason the testicles hang outside the body is because sperm likes to sit at about 35 degrees, where your body is at about 37 degrees. So the increase in heat has a real impact on sperm production. So we want to keep the testicles cool. So
Has anyone actually done the study on the laptop effect or the warm testes effect?
There's the warm testes effect. There has been a lot of research done on that.
Who's at risk?
Cyclists, particularly with their nice tight lycra. It's not looking good for you, Tim.
No, not only do I have my phone in my pocket, I cycled to the studio.
Yeah.
Danny?
Can I just, a little bit embarrassing, my husband's Dutch and we've been together for 10 years, and when my dad first met him, one of the first things that he said to him was, what's your bicycle seat like? Is it soft enough? Is it okay? And
well, they've said actually it's not so much about the damage, it's all to do with the wearing of the lycra and the heat that's generated, much more so than the actual damage of the cycling. There's some evidence to that, but most of it's about the fact that you wear nice cosseting shorts.
He doesn't wear lycra, it's all right then.
So you need to be letting it all hang free.
Anatomically, there are nerves that run along the bit of your body that then sits down hard on the bicycle seat, aren't there? And there was a suggestion that by sitting down hard on the bicycle seat, you can damage those nerves, and this may affect your function. Is that not such a consideration then?
Not so much of a consideration as the heat, but it is still a consideration, as is when patients have to have surgery that involves that kind of area. Then obviously what we would usually recommend is some kind of semen preservation, sperm preservation, because obviously it can lead to erectile dysfunction, which is more the issue than the sperm.
What about hot baths and things like that? Because, people love a good soak in the tub, don't they? Does that have a consequence?
As long as you're probably not soaking for hours on end, a hot bath now and again is not going to do you too much damage. But obviously, if you are actively trying for a family, we would be recommending cold showers. Cold showers.
A cold shower could have the opposite effect, couldn't it? That's not supposed to cool your ardour.
No, definitely not. Getting there together.
You heard it here first on The Naked Scientist. So, Tim, it's hot baths for you, Tim, then, is it?
I'll be taking a cold shower as soon as I get home.
So basically the bottom line is laptop not on your lap then?
Yeah, laptop not on your lap, on a desk. Or
mobile phone not in your pocket?
Mobile phone not in your pocket. Nice, cool cotton boxer shorts and cooler showers and not warm baths.
Thank you. Laura, here's another question.
Hello Chris, it's Sogat here from Nepal. I have a question about dandruff. Why do these dandruff keep coming back for some person? And is it the skin cell that is shedding? And why does it vary from person to person? And what can be the solution about it?
Well, first of all, what actually is dandruff? Well, it's very common. It's more common in men than women. It's more common under the age of 50, and it tends to have its peak onset after puberty kicks in. And that probably happens because once you go through puberty, your hormone profile changes. And your hormone profile, including testosterone and estrogen levels, affect the composition of the secretions that the glands in your skin and scalp put onto the skin surface. And those secretions include oils and other things. And that in turn affects the composition of the microbes, the so-called microbiome that lives on the skin. And that's probably the key to this, because dandruff is flaky skin. It's dead bits of skin, which is shed all the time. But when you get dandruff, what's happened is that the process by which the skin renews itself has, for some reason, speeded up. So you're growing more skin and losing more skin. And because you're losing more skin, you're more likely to see yourself losing more skin, which is why you get these little flakes of skin. It's nothing to do with hygiene. It does appear to be due to microbes, because there are various conditions which are associated with it, including an overgrowth of fungus, so certain fungi growing on the scalp perfectly naturally, and you often see this in young babies actually. They get something called cradle cap. When a young baby is first born, you end up with a flaky skin on the top of the head, and it's probably as their own microbiome is first establishing itself. You can also get dandruff if you're prone to eczema, which is another inflammatory skin condition, or sometimes just a certain change in products like shampoos and things which can irritate the skin can cause this to happen. And then some people have got psoriasis as well, and psoriasis can sometimes also cause a dandruff-like phenomenon. What can you do about it? Well, you can treat it with various shampoos, and they often have things like zinc in them. They might have selenium in them. These are things to look for in the ingredients. Things with zinc and selenium are very good because they actually affect the microbes that cause the dandruff. Also, salicylic acid, the chemical relative of aspirin, can sometimes also be in these remedies, and that's very good as well. And sometimes coal tar. In the old days, people used to use coal tar. It smells terrible, but it works a treat. And then there's an antifungus. You can rub in something called ketoconazole, which also can be used. And if you do this, it suppresses the fungus that causes the dandruff. The problem is, though, that if you are prone to that particular overgrowth of those yeasts and fungi that cause it, as soon as you stop the treatment, then you might get it back again. And this is exactly what is being referred to in the question, that it does relapse if you take the pressure caused by the shampoo off. So the best thing is, if you do get this, it's nothing to do with hygiene. People with perfectly clean hair get it equivalently with people who have dirtier hair. It's all to do with the microbes that inhabit you. And therefore, the best thing to do is to find a shampoo that's working for you and keep using it as long as it makes the problem go away. But, it is a pretty much a modern era thing, because we've all become so obsessed about hygiene these days, we tend to notice it. And I think the association with it being under 50, the cynic in me says probably because by the time you're 50 odd, you probably lost. Well, you've lost it. You partly because you don't care, but you've lost all your hair.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
You're listening to The Naked Scientists with me, Chris Smith, and with me a panel of experts taking on your science questions. Tim Revel is a New Scientist journalist. Danny Green is a marine ecologist from Anglia Ruskin University. Laura Carter-Penman is from Bourne Hall. She's a fertility nurse. And we have James Pope, who's from the British Antarctic Survey, and he models climate change. Now, we've got a quiz on the way for them, but before that, don't forget the quiz we have for you at home. We've got a game of Guess Who running through the programme. We've told you so far it makes a strange sound, which we played to you. We also learned this animal's eyeball is bigger than its brain. And your third clue is it can sprint at up to 70 kilometres per hour. Final clues are on their way, but what do you think it is? Now, I promised the panel of people earlier that we were going to have a little quiz to keep them on their toes. So this is the Naked Scientists Quest for Biggest Brain of the Week award, okay? 2 teams, Tim and Danny versus Laura and James. So Tim and Danny, you're going to go first. And basically, I ask the question, you get it right or wrong, you get a bing or a bong. Okay, your first question, what colour... Not a bong like that, Tim. Where are you coming from? This is a family show. Yeah, it's a family show. Tim and Danny, what colour dye do you get if you boil the sea snail, which is called murex?
Blue?
I'll defer to Danny.
Oh, it's really embarrassing if I get it wrong. I'm going to say blue.
Well, I'll give you 3 choices. How about that?
Oh, no.
That would help.
You can have red or yellow or purple. Which do you think it is? You're going to go for purple. Very
was
good.
that
Yes.
a bing?
Yes, it was a bing.
That's close to blue, isn't it?
Tyrian purple. It's made by boiling sea snails. The snails normally use the secretion in question to sedate their prey. It turns purple when it gets exposed to the air. It takes tens of thousands of these snails to yield just gram quantities of the dye, and that's why the purple was traditionally a colour that denoted high status, because it was so rare. OK, +1 for Tim and Danny. Very good. You're in the lead so far. It's good, given you only had one question. No competition yet. James and Laura, a giant squid is the same length as A, London Underground carriage, B, a minibus, or C, a double-decker bus.
My guts, it's got to be the longer one. I'm trying to think what's longer, a tube carriage or a double-decker bus.
My son is going to kill me that I've got this wrong because he tells me these sort of facts on a regular basis.
Can we phone a friend?
So we're going to go with the underground one. Do you think that's going to be the longest?
Yeah, we'll go with underground.
Underground. No, unfortunately, actually, these squid... Danny, you must know the answer to this, do you?
Was it the double...
It is the double-decker answer. Yeah, they get 12 to 13 metres in length, the giant squid. Double-decker bus is about 12 metres, so a colossal squid actually can be even bigger, 15 metres. So, Tim and Danny in the lead so far. Round two. Round two is a matter of time. Tim and Danny, there are trees alive older than the Egyptian pyramids. Is that true or is that false?
True. Because the Methuselah tree, wasn't that 5,000 years? How old are the pyramids? Actually, before we start.
A few thousand.
So, the Methuselah tree is 5,000 years old.
I think that's older than the pyramids.
Yeah.
Let's go yes.
So you're going
true.
That this is true.
Oh, yes. Another high five.
There are specimens of bristlecone pine in California and Nevada, and they are at roughly 5,000 years old, capable of predating the pyramids, the oldest of which were erected 4,600 years ago. They're not the oldest living thing, though. There are patches of, do you know what, Danny, another marine thing to put you on the spot, which are 200,000 years old. Seagrasses. Seagrasses, yeah. They've been documented as 200,000 years old, and they live in the Mediterranean Sea. It's a clonal organism that's been growing there in these patches for 200,000 years.
It's amazing.
James and Laura, can you redeem yourself? So these guys are on 2 so far. You've got 0. So you're doing well. Let's see if you can improve on 0. Time passes faster for your face than it does for your feet. Is this true or false?
Crikey. Time it's all to do with gravity, isn't it, I guess? And the gravity at your head is different to the gravity at your feet because you're further away from the centre.
Yeah, we'll assume you're standing up. Yeah.
So, I don't know. I'm still guessing either way. I'm not a physicist. I don't know. What's your thought?
I don't know. Your age shows more on your face, doesn't it? I mean, that's a basic one to go for.
We'll go with that, yeah.
Yeah, we're going to go with face.
Time passes faster for your face than your feet, true or false? You have to give me a true or false answer.
So faster for the face. Face is older, true.
The logic was dubious, but the answer was correct. Assuming you are standing up, Einstein's theory of general relativity, which of course you'll be very familiar with as a fertility nurse there, Laura, it states that the closer you are to the centre of the Earth, the slower time passes. At the top of Mount Everest, for example, a year is 15 microseconds shorter than at sea level. So time does actually pass a bit faster for your face than it does for your feet. You're off the bottom. OK, if they get this wrong, it goes to tiebreaker. If they get this right, then you really are not the biggest brains of the week. OK, here we go. This round is all about technology, and we want to know, does this technology exist? In other words, is it tech yes versus tech no? Do you see what we did there? That was cool, wasn't it? OK, Tim and Danny. Radiation blocking boxer shorts. Tech yes or tech no?
Maybe in Japan, because they have a lot of issues with radiation, don't they?
Yeah.
With like nuclear power plants and things.
Boxer shorts is a weird phrase here, because don't they sometimes put sort of things in front of you if you're having various scans to protect vital bodily organs? So they might not be boxer shorts.
They're always inventing things. I think it might be
I think it might be tech
true.
yes.
They might not work.
Are you going tech yes or tech no?
Tech yes.
You're going tech yes. Yep, it's unveiled at the Consumer Electronics Show this year. Spartan's radiation-blocking boxer shorts are made from a fabric which incorporates silver fibres woven into the cotton, so they block radio frequency signals from smartphones, and then they can't irradiate your private. So this, Laura would be very interested in this. You refer all your...
Tim needs these, clearly, so he can,
Yeah, I saw him. That's a question. I saw him and thought of this, yeah. But I was thinking your patients. You could say, look, you could get a set of these. The other bonus is that the the silver means that the underwear is also antibacterial, so that will keep coliforms at bay in your nether regions. Well, look, you have lost, but do you want to have a go at the... Do you want to see if you can sort of get 2 points anyway? You have a go, why not?
Go on.
OK, your tech yes or tech no is... trip-sensitive shoes that can summon help if you should fall over. Is that a tech yes or a tech no?
Tricky, because there's lots of technology
Tricky
out there to
or
help.
Trippy?
Trippy, definitely trippy, along with the techno theme.
My gran had one of those sort of panic buttons for when she fell.
Yeah, and there's you can get things that tell you not to leave the house now for dementia patients and stuff like that. So,
Are you going tech yes or tech no?
Yeah, I think we've got to go yes.
You're going tech yes.
Oh, I'm getting...
Hey!
Before you could snatch defeat from the
Yes.
top, I
was getting some evil looks.
I was like, oh no, really?
Evone have made some smart shoes. They've got accelerometers, gyroscopes and pressure sensors in them, so they can detect if you should take a tumble, so they're potentially very helpful, as you say, for elderly people, but also they have their eye on hikers and climbers whose adventures might lead them into remote locales where they could take a tumble. And apparently these shoes come with their own sort of network subscription, so they can send data and that kind of thing. So I guess you could say they come with a running cost.
Oh. Do they use them outside Wetherspoons on a Friday night?
I don't know, Matt, that could come in handy, couldn't it? OK, thank you very much. Anyway, our big brains this week. Give yourselves a big round of applause, and you can please salute our big brains. Danny and Tim, very well done. The prize is you go home with your reputation intact. Okay. Back to the questions. Danny, can you have a think about or ponder on this one for Sam?
Some people say we know more about space than we do our own oceans. Is this true?
What do you think?
In short, I'd say yes, it is, and particularly if you're talking about understanding the topography and the shape of the oceans. So, for example, we have got 100% of the oceans mapped, but the resolution is to 5,000 metres, whereas we've mapped 98% of Venus to 100 metres resolution.
So we do know quite a bit about quite a few places, but not necessarily the bottom of the sea.
No. But there is actually a big movement in 2017. There's a group called the General Bathymetric Chart of the Oceans, or GEBCO for short, and they're launching this huge effort to map everything in more detail by 2030. And this is a big collaborative thing, which would mean that, ships that are out doing things for fisheries or for recreation would also be mapping the oceans using multi-beam sonar, which is obviously a lot quicker than just a single beam at one at a time. There's this huge collaborative effort to map the oceans in more detail. However, some ecologists are concerned that this also may lead to a huge race to try to mine the oceans more. There's lots of precious minerals down there. There's diamonds, gold, obviously oil. We're already on the oil wagon. So there's an issue that, is this going to lead to conservation or to exploitation?
I wondered if you were going to say something else when you mentioned the sonar and conservation issues, because there is a question as well that one of the reasons we see things like big mammal beachings, whales driving themselves onto beaches, is because of distress caused by marine noise and underwater sound pollution.
Yes, exactly. So this is another big issue. It's also associated with oil rigs and the whole process of exploration of the sea as well as exploitation.
But is sonar of the kind used by shipping, is that destructive and disturbing to the
yes, it is.
environment
So
and the behaviour of these animals?
Yeah, so there's a lot of evidence that this is interfering with their navigation systems and causing them to beach.
So it's a bit of a worry that in order to understand the ocean, we could actually be doing damage.
It could be disrupting it even more, yeah.
Tim?
Why is the ocean not mapped much better? You'd imagine it's much, much harder to map the surface of Venus, millions of miles away, than it is to map the ocean floor.
But there's a lot of water in the way. Just in short, it makes it quite difficult. And obviously there's some areas that are mapped in a lot more detail. So we've mapped about 10 to 15% to 100 metres, because those are the shipping routes and the places we go to. But the areas that we rarely go to with really turbulent seas are going to be less well understood at this stage.
I spoke to a group of marine scientists at the University of Aberdeen a few years ago, and one of them passed on the sobering fact that he ventured, not personally, but with a probe, ventured to the bottom of the Pacific Ocean. It's about 7 miles, 12 kilometres down, a very long way down, and the first thing he saw when he reached the seabed was a plastic raincoat.
Plastic raincoat, yeah.
Yeah, he said it's just staggering. There's nowhere you can go almost where you don't see the destructive influence of people. That stuck in my mind for good reason. Now, sticking with the water, though, James, one for you. Chris has highlighted a question for us on Twitter, and Chris says, why are rising sea levels and melting ice caps a problem apart from the obvious?
People think about the obvious, about the inundation of coastal towns and cities, but some of the more probably less well discussed issues are sort of around freshwater sources. So the three types of ways we get fresh water. If you live somewhere like the Himalayas, you get it from monsoon rains and glaciers. If you live somewhere like the UK, you get it from reservoirs or aquifers. So aquifers are water storage underground in permeable rocks. What's possible is that near coastal regions, if the sea level rises high enough, it can actually flow and spill over from the sea into the aquifer and essentially poison the aquifer by introducing a saline component and making it no longer suitable for fresh water. Other issues, my mum lives up in Southport and they have a lot of salt marshes up there. So that's land that is at or just below sea level that gets inundated by the brackish water, so saline freshwater mix. So you get an entirely different type of ecostructure there. But obviously, if that inundated rice paddies or standard arable land here in the UK, you just lose the ability to grow crops in that area. But it's always worth saying that sea level rise is probably the least of our issues in terms of climate change. Under its most extreme scenario, we're looking at only a maximum of 1 metre by 2100 sea level rise, because the ice sheet, so that's the bit of ice that's actually on ground currently, it just takes a long time to melt. I mean, if you put some ice cubes on the desk right now, they take a long time to melt, and ice sheets take even longer. You're talking several thousands of years even to get some of the more vulnerable ice sheets to completely collapse. So it's probably not a huge issue immediately.
So it's not so much the actual water movement that is the issue, it's what goes with it. It's the mechanism that's driving the ice to melt that's causing a rise in global temperatures that's going to have other knock-on consequences directly for the inhabited land area rather than just a direct impact of sea level rise.
Yeah, I would suspect that most coastal regions would see impacts from things like extreme weather phenomena. You could argue that even half a metre rise makes a coastal area more susceptible to storm surges from hurricanes or even just bad weather like we see here in the UK. So it's not completely write-offable, but certainly it's not sort of some sort of dystopian flooded future.
And how much sea level rise are we looking at probably? You said the worst case scenario might be a metre or so, but how much are we looking at probably if we go following the trajectory we appear to be on? And let's assume, we end up with about a 1.5 degree rise across this century. What sort of sea level rise is that going to translate into?
So the 1.5 degree rise, so the recent report that the Intergovernmental Panel on Climate Change produced on this, they estimated it would be somewhere in the region of about 0.6, I think, with an uncertainty range of about 0.3 to 0.7 of a metre. So there's an element that we're sort of committed to a certain extent. But I think from memory, a lot of that is mainly due to just the warmer planet means that actually the ocean, the size of the ocean just expands, the water expands in size. So it's thermal expansion less than actually the melt of ice sheets and glaciers.
Because the poles have melted in the past, haven't they, in Earth's history? We have had a planet in the past where there was no ice at either pole.
Yes, and conversely, when we had the last glacial maximum, so about 20,000 years ago, sea level was as much as 120 metres lower. So in some respects, we've had 120 metres of sea level rise. We could, if we melted everything that was left, get another 70, but it would take an awful long time to melt everything that was left.
So that's sort of reassuring and not reassuring all at the same time.
And I guess it depends where you live. If you live in Cambridge.
Could be Cambridge-on-Sea before too long. Thank you very much, James. I'm glad I invested in that property. I'm going to have a beachfront property. I'm going to keep driving my car as much as possible now to drive up sea level rise. Of course, I'm not. I'm taking it all very seriously. James, thanks very much. Laura, can you help us with this? David on our forum has said, what do we actually mean by the word infertile?
Infertile is actually quite an old term that was used, really. We say that couples are infertile if they've been trying for a year and haven't conceived naturally. But we would actually consider most of our patients to be something called more subfertile, really, that they have issues with their fertility, but that can be assisted. Or mainly, there's a lot that can be done with just lifestyle changes. Weight has a huge impact, smoking, alcohol, heat, we talked about, stress factors, environmental factors. So really, I think infertile is quite an old-fashioned term, and we should be moving to more the term of subfertile.
To what extent do you think that the rising trend in infertility is because of our modern lifestyles? We're living life where we're burning the candle at both ends, aren't we?
I think it has a huge impact. We like to have it all and do it all, as females. We all want to have these amazing careers, and unfortunately our bodies don't match with that. Our bodies still want us to be having children in our 20s and early 30s. Our bodies aren't designed to be having babies in their in our late 30s and early 40s. We spend a lot of time talking about reproduction in schools and how not to have children, but we don't tell people when to start having children.
So what should we be saying then?
I think we should be explaining how you get pregnant. We need to go back to basics, but we need to be explaining to people that, when fertility is going to have an impact. For women, it's 32, 33, 35 is a real start of the cliff. And it does have an impact on men as well. You see lots of, older, Mick Jagger with his hundreds of children that he seems to be having. But
allegedly.
I think, yeah.
And that what gives people the impression that, I can put it off till tomorrow.
Yeah. And I think, lots of older pop stars, funnily enough, they all seem to have twins in their 40s really easily, makes you think, are they actually having reproductive therapy and not talking about it? So I think we should be being more honest with ourselves and more honest with the younger generation, and making it easier to be back to work, all the things that go with that, the social factors that go with that you can be at work and be a mum, and it's not a bad thing.
Thanks for that, Laura. OK, Danny, how about this one for you? This is from Tamsin.
Do immortal jellyfish really exist?
Perish the thought. Immortal jellyfish. Is there such a thing? Could there be such a thing?
Yes, so it's not immortal in the way that in the old movie The Highlander is immortal. So you're not chopping off heads and absorbing their powers, unfortunately. But yeah, there is a jellyfish called Teratopsis dorni, and it was actually discovered by accident by a lazy grad student who was doing some experiments on them over the summer, and his name was Christian Sommer. And he had the Medusa in the tank, which is the jellyfish form that we know and love, the adult form with the bell and the tentacles. And he sort of left them over the summer, and he went off and went on holiday. When he came back, he expected to find some dead Medusa, maybe some polyps. All he found was polyps, which is the juvenile form. That's the form that sits on the bottom, and then that eventually grows into smaller Medusa, and then they are sexually reproductive, and then they produce planular larvae, and they come back down into polyps again. And all they found was polyps. So we thought, that's strange. What's happened? Where are all the dead ones? Where are all the different stages? So then they did some experiments, and they discovered that what was happening was that when these animals get stressed, they revert to a juvenile state. So it's a little bit like the Benjamin Button of Nidaria, I guess. So they get stressed, and then they can go back into being a polyp, and they can go again, and they can do it again. They can do it for forever, as far as we know, in a laboratory system at least.
So they transform the body of the big one, the parent, for want of a better phrase, into lots of little blebby off bits, which are the polyps.
Back into one, and it's a little bit like a butterfly going back to a caterpillar. It's a bit like that.
But it's also it's reabsorbing and sort of deploying all its body parts to make it a totally new form of the organism.
Yeah,
and not just one, but many.
Yeah, so it's a process called transdifferentiation, and apparently there's talk amongst medical scientists like yourself to use this in a way for human health and to reduce the ageing process.
But if what you're saying is true, that these animals can just basically turn themselves back into a more primitive form of themselves, there will be some jellyfish cells in the adult that turn into juvenile jellyfish cells. But then when those little ones grow up to make big ones, they're going to make new cells, aren't they? So the cells that are in there are not... There might be the odd cell that's from the original parent, but they'll have grown to make lots of newer cells, won't they?
Yeah, exactly.
So is it strictly immortal then?
Well, it's immortal in the sense that it can just keep going sort of again and again, ultimately. I'm not sure.
Is that not
it's
like,
not immortal in the sense
that like a human being can reproduce. I mean, Laura will know. And you take an egg cell that an adult has made, but actually made when her mother was pregnant with her, and that egg is then fertilised by a sperm, and from that one cell, you then make a whole new organism. But at the same time, you've still made all new cells. So you could call a human immortal then, in the sense that it's sort of similar to what the jellyfish is doing, isn't it?
It's not. Yeah, I mean, I suppose technically it's not immortal, but it's probably the closest thing that we have on Earth that we know of to immortal, perhaps.
Why do you think the jellyfish do this? Is it some kind of defence mechanism?
I think it's a defence mechanism, preservation. Now, it's not been observed in the wild, keep in mind, because obviously this is a difficult animal to study. It's only been seen in the laboratory, and as far as we know, it can just keep doing this over and over. And even if you pinch them with a pair of forceps, they can do this within 3 hours. They can revert back from the Medusa stage back to the polyp stage, so it happens very quickly as well.
Yeah, well, that could be useful in medicine, couldn't it? If you needed to sort of repair a bit of yourself and you could just grow another one. Well, there you go, Tamsin, that you can have a sort of near immortal jellyfish.
Yeah.
And I didn't know that. Thank you very much, Danny. And moving on, Tim, Frankie has a question for you. She's from Cambridge.
My question is, how much will technology feature in our future? Will it take our jobs?
So is Frankie out of a job owing to technology and AI and all that kind of thing you were discussing earlier?
I guess it depends what Frankie does. And it also depends who you ask. So one very famous study that looked into what jobs will be automated in the future came from the University of Oxford. And they reckoned that about half of all jobs in the US and a third in the UK were at high risk of automation. Basically, the job would be given to a robot at some point in the following 20 years. But since then, that study has been questioned a lot, and a lot of people say it's actually a lot lower. And so it's really, really hard to know what's actually going to happen in the future. But I think there are some examples from history to look at. And one of the things people talk about is, will robots actually create more jobs than they take? And so the famous example of this is the job of a bank teller, someone who you talk to at a bank to help you with your banking. Many years ago, the ATM was invented, and people said, well, that we'd have no need for bank tellers anymore because you go to a machine and it gives you your money and tells you your balance. Why would you need a person anymore? But what happened in the next 20 years was actually it became so much cheaper to open a bank because most of the work happened at the ATM machine, that more banks were opened. And after 20 years, there were more bank tellers after the invention of the ATM than there were before. So some people are suggesting that automation in its current wave will have the same effect. Lots of jobs will become automated, but people will then get extra jobs on the back of that, and the sort of more manual or less interesting parts of the job will be automated away. But the short answer is we just don't know yet.
It's a worrying time, really, isn't it? Do you think scientists will always have a job, though? Because someone's got to dream up...
Asking for a friend, Chris?
Yeah.
Or?
I guess so. I would think also maybe journalists as well, because asking the sort of hard questions and conveying it in a way that you think people are going to be interested in it, I think that's going to be quite a tough act to match, isn't it?
Definitely, but there are aspects of this that are already being automated. In terms of journalism, there are AIs that will look at academic papers and write them in short summaries. That's almost my job currently. So there are loads and loads of aspects of this. There are also AIs that will look at, for example, social media and make a story out of that, which many journalists also make a living. So I think no one is completely safe, but there will be new things for us to do, and perhaps the mundane aspects will be automated away, hopefully.
Let's keep our fingers crossed. Thank you, Tim. Now, James, got a question here from Donald on the Naked Scientist forum. That's nakedscientist.com/forum. He says, if the Earth wasn't tilted, what would be the impact on our climate?
It's a brilliant question. The short answer is that basically every single day would be 12 hours long everywhere. But your latitude would affect how high the sun was in the sky. So if you're at the equator, you'd always have sort of 12 hours with a very high midday directly in the middle of the sky sun. If you're at the poles, you would have a very low, right on the horizon sun for 12 hours a day. So the energy we get from the sun comes in. You can sort of imagine if you took a football or something and just put straight lines towards this football, that's sort of the energy from the sun. Without that tilt, all of that energy would go into the equators. There'd be less energy going into the polar regions, so you'd have more energy transfer from the equator and the low latitudes up to the higher latitudes. So in the mid-latitudes where we are, we'd probably get stormier because there'd just be more movement of air. And overall, the UK, it'd probably be much like sort of the week before Easter, permanently.
What, with the traffic, you mean? Or but being more serious for a minute. So basically, the temperature we experience is because it's the amount of solar input, the amount of energy falling on the land for that length of time. And so we have summer because the Earth is tilted and we see more sun during the summer period, and we have winter because we see a bit less because that part of the Earth's surface is tilted away so the sun's not as high in the sky.
Yep.
So basically, it's thanks to the fact that the Earth is tilted that we have seasons, and therefore we have a seasonal climate.
Yes, exactly.
Yeah, because someone said to me the other day that Mars is also tilted because the Earth is tilted 23.5 degrees, Mars is tilted about the same, so therefore Mars sort of has seasons as well, but it's a great deal colder than it is here on Earth.
Earth has got very lucky. It's in that we're in this really nice little slot in the solar system where if we were a few 100,000 kilometres nearer or a few 100,000 kilometres further away from the sun, it may be almost uninhabitable. And it's that sort of that variation. We're just in a real sweet spot, and our tilt aids that. But also that tilt is what added to things like the ice ages. So the glacial interglacial cycles where huge ice sheets waxed and waned over, especially northern Europe. That is part of that was due to the changes in the tilt and also the change in the shape of our orbit around the sun.
So why should the tilt change?
I don't actually know. I think the tilt was sort of very early on in the Earth's formation. The Earth was slightly knocked off its spinning axis, so it put it onto that slight tilt, and it's just got a natural wobble, like a sort of spinning top, essentially.
And so, owing to the fact that it is just gently changing that degree of inclination over very long timescales, is that why we go through phases of the Earth's a bit warmer for a while, it's a bit colder for a while, and that's what people call the natural cycles, or sort of Milankovitch cycle?
Yeah.
So when people say the Earth has always, throughout its 4.5 billion year history, gone through cycles when the climate has changed, how do we know that the warming that we're seeing today is owing to our influence and not just the Earth entering another of these natural variations? Because the Earth has completely frozen up in the past, it's completely melted its poles and been really, really hot in the past, hasn't it?
It's one of the toughest parts of climate science in many respects. So we have different ranges of data. Some of that is the modern day satellite observations, weather stations. That's all very new, recent, last 50 years. We have proxy data, which comes from things like tree rings, the ice cores, or even sediment cores from the deep ocean. Like we can go back about 65 million years for some of these sediment cores, and we can, looking at the fossilized plankton and the chemistry of the shells, we can approximate what the temperatures would have been. But ultimately, what we can see is that nothing has happened as fast. Nothing that we've really seen happens as fast as what we are currently observing. And that's that rate of change that makes the anthropogenic effect, the man-made effect of climate change, different to natural climate change, which has always happened and will continue to always happen with our signal on top of it.
Thank you for that, James. Laura, let's move over to you. Sophie has been in touch on Facebook and wonders if you can help her out with this.
When during their monthly cycle are women most fertile?
Well, most women average a 28-day cycle. Some ladies have slightly shorter cycles and some have slightly longer cycles. And most ladies ovulate about halfway through that cycle, so around about day 14. So from a fertility perspective, we would usually recommend sort of regular sexual intercourse from around about day 10, because sperm lasts sort of 5 to 7 days. An egg will only last sort of 1 to 2 days maximum. So ladies are mainly fertile from probably about day 14 of their cycle round to about day 21 of their cycle.
So it's all to do with ovulation occurring on day 14. But what about if a person doesn't have a regular cycle? Because the data you've given us assumes that a person knows where they are in that cycle. So what happens then?
So for us, we might recommend that you have some scans so that you can see what's happening, to see what the follicle production is going on within your cycle. Patients can try using luteinizing hormone sticks, those sort of surge kits as they're called. You can buy them over the counter. Pee on a stick and it tells you whether you're ovulating or not.
Okay.
Obviously, for ladies then that aren't detecting that, they may need some help with something like clomiphene, a reproduction of a follicle stimulating hormone that usually occurs naturally but isn't in those ladies.
So that encourages the chemical process of
ovulation. Yeah. And then obviously we would link that again with scanning so that we can see that there is a follicle production as well.
So roughly what fraction of people do have a regular cycle and what fraction have irregular cycles?
So probably 1 in 6 ladies have an irregular cycle, so it's quite a high proportion really. I mean, we keep focusing again here on sort of female factor, but actually 40% of problems are male factor problems, 40% are female. 20% sometimes sit between the unknown and also is a mixture of two. Quite often it appears that patients are drawn together if they both have an infertility issue.
Oh, well, they say opposites attract, but not in this case. James, you were going to say?
Yeah, I was going to wonder, you're talking about sort of kits you can buy over the counter. Would you put any stock in smartphone apps that sort of suggest your fertility in the cycle?
Yeah, there's lots out there now which help you track your cycle. They would recommend that you track your temperature because there's supposed to be a slight temperature rise when you ovulate. There's now a bit like Fitbits and things like that. They're now out there for fertility as well. It's a big sort of up and coming burgeoning market within that side of things as well. And can help with tracking.
Do people say they find they're useful, or do you think it just helps people to focus their mind? They get a plan in place and so they tend to stick to it, which means they're more likely to be successful.
For some patients, it's really helpful. It gives them a focus. For others, it just absolutely adds to the stress of the situation. And we would recommend that they go and seek help from a specialist, go and see their GP, speak to a fertility nurse. There's lots of things out there to help, and actually the apps are useful, but I think sometimes for patients who are really struggling, it's not the best thing. It really adds to their stress.
And some people use these apps because they don't want to get pregnant. Is that a risky strategy then?
I would say that's a very risky strategy.
Laura, thank you very much. And it is no laughing matter, obviously, if it does go wrong, because it spells disaster for some people, doesn't it? Right, time for the final clue for our Guess Who I Am. My scientific name is Struthio camellus. Struthio camellus, and I have 3 stomachs. Does that give it away, team? What does everyone think? Do you know what our thing is that makes that funny grunting noise? It can run at 70 miles an hour and has an eye bigger than its head. What do you reckon, panel? James, go. What do you reckon?
I'm going to go out on a limb here. I'm going to go for a camel.
He's going camel?
Camellus.
Any advance on camel?
That's a hint.
When you said that the eyes were massive, I thought it was some sort of monkey thing. But I'm not so sure now with the 70 miles per hour and the 3 stomachs. That's thrown me.
I thought it could be like an ostrich or something like that. They can run quite fast and they have
big eyes.
Big eyes. They do have big eyes, yeah.
It is an ostrich.
Struth,
yes. Oh, well done.
It is an ostrich, yes. The
Struth
answer
is an Australian kind of exclamation.
That must
Struth's
be why.
craggy.
Look at the size of that ostrich.
Yeah.
Well, there we must leave it this week because the arrow of time has defeated us. But just before we go, we would like to ask you, please, to help us. We give you our programmes every week for free, and we hope you enjoy them. But we do, of course, have to meet our running costs and also to pay our very hard-working staff. And that means we need to raise funds to do this. And to safeguard next year's programming, we need to raise £50,000 by the end of this year. Now, the good news is that if everyone listening to just this one single programme were to contribute the cost of a single cup of coffee, then we would have sufficient funds for the next few years, not just this one. So look, please, if you appreciate what we do for you, consider buying us a virtual cup of coffee for Christmas. We've explained how you can do that at nakedscientist.com/donate. Thank you very much for listening, and thank you for sending in your questions so that our panel, Tim Revel, Danny Green, Laura Carter-Penman and James Pope could answer them for you. Izzy Clark put the programme together. Do join us at the same time next week when we're going to be discovering the marvels of manufacturing. How do things get from the brains of engineers and turn into the stuff we need? Tune in to find out. The Naked Scientist comes to you from Cambridge University and it's supported by the EPSRC and Rolls-Royce. I'm Chris Smith, and until next time, thanks for listening and goodbye.